Hi user, welcome to my channel Learning with Khatak. In today's lectures, we will create a single perceptron in a neural networks with the user inputs, the weights value and the bias value, and then we will calculate the dot product of inputs and weights plus adding the bias value and then finally showing the output values. Basically, this is a three-step process. This how to initialize inputs, weight and bias values, and then how to calculate the weighted sum, and then how to calculate the output, and finally display the output. So basically, in today's lectures we will implement this diagram. If you look at this diagram, in this diagram we have two features, feature 1 and features 2, with the user defined values zero point 0.7 and 0.53, which have a certain weights W1 and W2, W1 for feature 1 and W2 for feature 2. So here in this portion, basically we perform the dot product, which is basically multiplying the inputs with the weights, and then after summation added the bias value. In this case the bias value is 0.01, and then finally we will show just the output. There is no use of activation function. For activation functions we will hopefully develop another program. Okay. For how to initialize the inputs values, weights and bias, simply if I have two values x1 features, so this is basically x1 features, which is according to the diagram 0.7, and x2 features which is equal to 0.3. So these are the two input features. Okay, then we have two weights and w1, so weight 1, which is 0.5 in this case, and similarly weight 2, which is 0.3 in this case. Okay, sorry, which is 0.3 in this case. And another thing is bias. So bias value, which is in this case 0.1. Okay, so these are the basic in basic initializations every perceptron or neuron will require before firing it. So then first we have to compute the weighted sum. That how the weighted sum is basically computed. Basically weighted sum is the product of weights and inputs. So how to calculate the weighted sum? Simply, okay, weighted sum is equal to okay, let me run it. But before running it, I forget one thing. Let me initialize the numpy array. Numpy is np. Okay, so I run this code, then this, and then here I am going to now x1 sorry, x1 feature multiplied by weight 1 plus the second feature, which is x2 features, and multiplied by weight 2. Okay, so if you look at this, if you look at the diagram, what will happen here? This feature is multiplied with this weight plus this weight is multiplied with this features. So this is basically the weighted sum, and then calculate the output. Okay, in output what we have to do simply is the just adding the output, sorry, bias value output is equal to weighted sum. Okay, let me run it. Okay, weighted sum plus bias. So if we look at the diagram, uh, okay, so I think we have changed the name of bias values. Yes, so if we look at the diagram, what we have did so far, we have initialized the feature values. We have two features, and then we have initialized two weights for the corresponding input features, and then we have initialized a bias value. Then here we have performed the dot product which is basically dot product of inputs and weights, and then the output we just adding bias value to the weighted sum. Okay, finally we are going to displace these values individually. For example, just I want to show, I want to know the input values, or I sometimes call it features, input values and features for the perceptron. Which are the values for the perceptrons? For examples, these values are uh, first I would like to display the input features, that is x1 feature, x1 features, that is x1 features, and then print print x2 features, and this is the x2 features. And then I just want to know about what are the weights of the single perceptron. So weights of the perceptron for the input values. Okay, what are the weights respectively? Okay, let me do it one thing here, just to show clearly the values of inputs and weight separated. So print weight for first feature, weight for first feature, that is, oh sorry, weight for first features, that is weight 1. Okay, and then I just want to copy this weight for second feature, that is feature 2. Okay, similarly I just want to show the bias value, print bias value for the perceptron. Okay, this is again I would like to separately display. Okay, and then simply print the bias of the perceptron, that is bias value, and then finally I would like to display the output, print the output of the perceptron without using activation function, because I'm not using here any activation functions. So output means, if you look at this print, the output is output is output. Okay, so if I run this program, simply look at this, these are my input features, 0.07, 0.3 weights of the perceptron for the input values, these are the input values, and bias values for the perceptron, that is 0, 1, and then the output of the perceptron without using activation function is 0.533. Okay. Now if you look at the graph, This is 0.51 or 0.53 means basically this is the process of how to create a perceptron. Three-step process. Initializing the features or input values for the perceptron, and then initializing these are basically the basic parameters which needs to be initialized: input features, weight, and bias values. The second step is the weighted sum of dot product of inputs with the weights, and the third step is adding bias and then simply displaying the output. So this is a very basic simple versions of the perceptrons where we initialize the input features, the weights and bias, and then apply the dot product and simply display the output. In other words, we have implemented this diagram. Okay, if we look at this, we can change little bit this code, like if I'm going to write the features, I can write uh, features in or input features. This time I'm going to use the features using numpy array. So this is the two values 0.7 and 0.3. Okay, these are my I can also declare the input values using numpy array, or just for simplicity I have declared here the two features, but you can also do like that. For this reasons, when you perform the dot product, now the dot product will be, now you have to change this line accordingly, and that will be weighted weighted sum is equal to, now this time np dot that will be, let me run this so that features, okay, input features and weights and weights. Okay, yes, of course you have to change the weights declaration also here using the numpy array. So weights will be like that, np dot array, sorry, np dot array, and weights are basically 0.5 and 0.3. So if I run this, okay, now dot product of input features and weights, this is basically now the weights, and then plus bias. Okay, if I run this, okay, bias value is not and bias value, okay, and then this is the output. Now again if you look at the output, अगेन वी हैव अ सेम आउटपुट. ओके, सो अगर यहाँ पे आप लोग देख लें तो हो यहाँ पे जो बुनियादी फ़र्क मैं बताने की कोशिश कर रहा था कि यहाँ पे हम इनपुट फीचर्स इस तरह भी इनिशियलाइज़ कर सकते हैं, और इस तरह हम यूजिंग एन पी अरे, नमपाई अरे को भी हम यूज़ करके इनिशियलाइज़ कर सकते हैं. लेकिन अगर आप एन पी अरे यूज़ करते हैं, नमपाई अरे के थ्रू करते हैं, तो फिर यहाँ पे जो आपने वेटेड सम कैलकुलेट करना है वो आपने क्या करना है, एन पी डॉट डॉट प्रोडक्ट. अब ये बेसिकली डॉट प्रोडक्ट क्या करता है, डॉट प्रोडक्ट आपको ये करता है कि ये इनपुट फीचर्स एक अरे है और वेट्स आपके पास दूसरी अरे है. तो ये क्या करेगा, एन पी इनपुट फीचर्स के अंदर जो फर्स्ट एलिमेंट है, दिस फर्स्ट एलिमेंट विल बी एडेड विद द दिस फर्स्ट वेट, एंड देन एडिंग प्लस, एंड देन द सेकेंड वैल्यू ऑफ द इनपुट फीचर्स अरे. तो यहाँ पे अगर आप लोग ये दूसरी वैल्यूज़ देख लें, ये दूसरी वैल्यूज़ वेट्स के अरे के अंदर दूसरी वैल्यू के साथ मल्टीप्लाइड होगा, दोनों वैल्यूज़ प्लस होंगे, और फिर क्या होगा, 22 की वैल्यू ऐड करेंगे और फिर आपके पास आउटपुट डिस्प्ले होगा. ओके, सो गाइज ये तो हमारे पास था सिंपल सा एक प्रोग्राम जिसके अंदर हमने डॉट प्रोडक्ट लिया था, कोई एक्टिवेशन फंक्शन हमने यूज़ नहीं किया था। अपने नेक्स्ट लेक्चर्स के अंदर जो हमारा टास्क नंबर 2 होगा, उसके अंदर बेसिकली हम क्या करेंगे, एक्टिवेशन फंक्शंस भी हम यूज़ करेंगे, फीचर्स हम बढ़ा लेंगे, नंबर इनपुट फीचर्स हमारे पास 3 आ जाएंगे, और फिर जो एक्टिवेशन फंक्शंस है वो एक्टिवेशन फंक्शंस हम अप्लाई करेंगे। एक्टिवेशन फंक्शंस के साथ जो सिग्माइड एक्टिवेशन फंक्शन है, एक्टिवेशन फंक्शंस के साथ हम स्टेप फंक्शंस भी यूज़ करेंगे कि जब हम स्टेप फंक्शन यूज़ करते हैं तो हमारे पास आउटपुट क्या आती है, और अगर हम सिग्माइड फंक्शन यूज़ करते हैं तो उसके थ्रू हमारे पास आउटपुट क्या आती है, और दोनों के अंदर फ़र्क क्या है बेसिकली। सो वेट फॉर द नेक्स्ट लेक्चर। थैंक यू वेरी मच।